All right. Your written test number 2 will be this Friday, usual time. Just please take a look at the guide and then to see what's required and the coverage. So whatever I covered today about typecasting will be covered for Friday. But if I cannot really cover as much as what I specify in the guide, I'll adjust it. So don't worry. So whatever we can cover today, that'll be it. Definitely about typecasting. The typecasting coverage today will be a bit intense. So if you really find it too heavy, do stop me for questions, right? It's important for you to understand first. Otherwise, I'll just go with, as planned. There will be a review session tomorrow, Wednesday, most likely 4 p.m. But I'm still waiting for confirmation from the department about the location, but I'll let you know. Okay, could be Curtis Lecture Hall, could be Ross Building, I don't know. I don't know yet. I'll let you guys know as soon as I got notified. Your lab number 4, I extended the deadline slightly until midnight Thursday, just to give you a little bit more time. Since we're also going to talk about typecasting, instance of, also today and also Thursday, you can also take advantage of using them in your lab. But the slides have been there. You definitely can study on your own as well on the slides, right? If you want to wait for me to cover that in the class, that's fine too, okay, either way. And then I'll let you guys know pretty soon about your final programming test, which will be not the coming Friday, but the Friday after, right? Next Friday, right? It's all, everything's on schedule. All right. Guys, any questions about the course? All right, we still got, about 5 classes left. We still got quite many exciting stuff to cover. So, just sit tight and look forward to it. Let's do some quick recap about last Thursday. And then move on to typecasting. So last Tuesday, we actually talked about, last Thursday. Just got confused with the dates. So we talk about expectation. So basically, when you're given some inheritance hierarchy, how can you figure out the expectation? Expectation is really about what methods or attribute you can call on an object of certain static type, right? It's really about the expectation. And the lower the hierarchy, the lower the class is in the hierarchy, the more expectation you can have. That's the principle, okay? And then we talk about this particular page. That's very important. You want to really take a look at that and see the definition for ancestor and also descendants and also about expectation, right? That's something we kind of build up from scratch. That's something you can definitely look at the recording from last Thursday, from Tuesday. Yeah, sorry, whatever day. And then we talk about the code reuse. It's really about expectation, right? Similar. So let's say this is the highest one on the hierarchy, so that one has the fewest expectation. On the other hand, this one is rather lower in the hierarchy, so you have more expectation, right? So that's something you really want to feel comfortable with when you actually write the test on Friday. Okay. All right, and then let's say reuse. Yep, that's also something we said. And you want to think about, if I got SP1 over here, if I put either SP2 or SP3, how can I decide whether or not it should compile? And we said, to really decide something about compilation, you have to look at the static type, right? That's something we said. And for the precise reason, that's something you can also go back to the lecture and see why. Usually it's about whether the right-hand side should have the static type that's a descendant class of the static type for the left-hand side, right? That's the rule. And it's how to understand the rule, that's something you also need to review, the lecture. All right, and then expectation, just additional examples over here, right? You can see if I talk about NRS, it's basically its own expectation, like a new attributes and new methods, plus whatever expectation from its parent class, right? The child class always inherits the expectation from its parent class. All right, that's another important page from last class. So this is about the rules of substitution. The problem goes like this. If I have some variable assignments, like OA is assigned OB, in order for this variable assignment or substitution to really compile to work, you have to look at the static type for OA. Let's say in this case it is A. Given that the left-hand side is already the static type, it's already fixed to be A right here. What would be the range of classes for OB's static type? That's still going to make the compilation happen for this variable assignment. And we said that it should be all the classes that can fulfill the expectation for OA static type. What are the classes that can fulfill A? All its descendant classes, including itself. Anything that's starting from its parents and all the ancestor or something that's neither ancestor nor descendants, they cannot fulfill, right? You can see all the discussion here is based on something we talked about over the past few classes. So you really got to make sure for Friday and also even longer for the exam, you have to make sure you feel comfortable about such reasoning. It is really the essence about inheritance. Any question about this? Okay. All right, so that's the rule. Just to summarize, right? You want to look at the static type for the right-hand side and the left-hand side, and that's exactly the condition. But of course, I wouldn't recommend you just memorize it. It's not going to lead you far, because I might give you something that's probably symbolic, or maybe something that's a little bit more complicated than what we discussed in the class. You really have to be able to think about the reasoning. All right, these are just exercises for you. They're rather similar, rather simple. You can also see the solution on the slides. Okay. And then, okay, I believe, okay, almost there. So about dynamic type. So whenever you visualize the objects, you definitely should put the dynamic type here. That's about the title of the box. And then the reference variable is currently pointing to some dynamic type. It's static type. You may want to visualize that as well, just to remind you. And this static type here never changes. And then we had some tracing earlier, with the same variable, the same static type. We want to see how we can change the dynamic type from one to another. And so the substitution over here is you got to make sure, given that Jim has this expectation for students, that's declared statically. You want to make sure any dynamic type you're going to assign Jim into, they must be able to fulfill the expectation for students. What can fulfill the students' expectation? It's descendants. What will be the descendant for students? Itself, resident students, and non-resident students. Right? Similarly, if you look at the example in the smartphone hierarchy, the same principle. It's just that there are more classes for you to consider. Okay, so make sure you can do tables like this just to trace the dynamic type. And then, yep, there's something similar. So this one here, this variable assignment is not going to compile because the student here cannot fulfill the expectation for resident students. Right? Because student here is simply an ancestor class. It's not a descendant class of resident students. Right? So you really want to be sure. Like the direction is only one way, but not the other. All right, let's see here. Yeah, so these are all examples for you to look at about dynamic binding, which we also spoke about earlier. All right, so I believe that, yeah, that's the last page that we spoke about last time. Just about polymorphism and dynamic binding. Polymorphism simply means once you declare the static type, which might be somewhere in some inheritance hierarchy, once you declare the static type for some reference variable, what can be the dynamic type for that particular variable? It will be a range of descendant classes for that. So there could be multiple shapes. That's at the runtime. So that's called polymorphism. So polymorphism is really about once you fix the static type, what can be the dynamic type accordingly. Dynamic binding just goes one way ahead, just go one step forward. So once everything compiles, you try to execute the method call at the runtime. Depending on what's the dynamic type for the reference variable, you want to call the corresponding version for the method, right? That's also something we said. So polymorphism, dynamic binding are arguably the most important two things you want to really make sure you understand and be able to express yourself what they are when we talk about advanced OOP. All right? Any questions before I move on? All right, so today, my only topic will be typecasting. But there will be quite a bit to talk about for typecasting. As I said, today could be a little bit intense and could be confusing for many of you. If you're learning this the first time, that's okay. Feel free to interrupt me for any clarification. As I said, for now, I put the coverage for the slides for Friday's test to be a certain number. If I really cannot go that far, I don't mind narrowing that for Friday, right? I just want to make sure you guys are okay, right? They will be covering the exam ultimately anyway, right? Okay, let's now talk about typecasting, right? Let's now try to understand why we actually are motivated to do typecasting. Let's start with some simple example, okay? Okay, the example I gave to you, I believe there are two examples there, but I'll just talk about one of them. Let's say we got only 3 lines of code right here. All right. Why don't you just just spend about 30 seconds. Let's take a look at these 3 lines of code. We are still using our familiar student management system example. Take a look at these 3 lines and then tell me whether or not it's going to compile. If you have already thought through what we have covered so far, it should be a very straightforward answer, whether or not things will compile, right? So your answer can be either everything will compile, or tell me which line or lines that would not compile. Okay. Let me switch the iPad here, the same 3 lines, right? So here you also got the student, resident student, non-resident student, right? That's a hierarchy. All right, anyone. Is this going to compile? Any idea? If you know, I'll just tell you the answer. Okay? It turns out this one here is not going to compile. Which line? Let's go line by line. This one, so this is a variable assignment, this is a variable assignment, this is a method call, right? This method call here, only look at this line. It's going to compile because RS declare as statically a resident student. Does resident student have set premium rate expected? Yes. So this line here, no problem. What about line number 1? Can resident students fulfill students? Yeah, because resident student here is a descendant class of students. So the direction seems right. Now, if you look at line number 2, can the static type of gym, which is students, can students fulfill resident students? No, it cannot, right? You can see the direction is wrong. So line number 2 is not going to compile. However, this is exactly where typecasting could be useful if somehow we know that we are smarter than a computer. We know what we're doing. Okay? Let's now visualize this a little bit more. Okay? So the conclusion, first of all, this line here is not going to compile. And the reason will just follow what we said earlier in the lecture. Whether or not it's going to compile is not a new subject, right? So let's now try to visualize it. What's happening here? At least we can try to just visualize what we intend to do. Line number 1, first of all. Okay? Let's visualize just this one here. So what we have is we have gym statically is a students. I can make it more explicit for you. So student here is the static type for gym. All right? I can move gym away a little bit. Okay? And then we say that dynamically it is a resident students objects. So that means gym will point to an object dynamically of type resident students. And we know pretty well resident student has some new attribute there that's newly introduced. Premium rate, for example, right? Premium rate. Okay, like that. Yeah, in the beginning, it's simply 0.0, let's say. Okay, nothing's there. So this is really about line number 1. Now, for line number 2, what we intend to do is to say RS is going to point to wherever gym is pointing to. And later on, we want to call set premium rates on RS, right? However, Eclipse compiler or any Java compiler tells you that you cannot do it, simply because the static type for RS is resident students. You cannot assign you cannot really assign students into resident students. So it seems like the limitation is on the compiler side. All right, let me just do it again. Okay. So think about what we're declaring over here is RS, and the static type there is resident students, right? Again, this is static type. And Java compiler tells you that if I try to say RS is going to point to wherever gym is pointing to, it tells you that you cannot do it. You just cannot, right? So this one here, you just cannot do it, right? For the reason we said, the static type for gym, which is students, cannot fulfill the static type for RS, which is resident student. You just cannot, all right? But why is that so inflexible? Because I know that dynamically, this is indeed a resident student object. Why can I not do it? Why is the computer so limited? Why can it not tell? Let me write it down, and then I'll give you guys an A+ challenge. to consider. All right. RS over here, we say that it since that the compiler is very limited. What Jin is pointing to is a resident students which should support support so we can fulfill the expectation, which should support the premium rates right here. But somehow when we try to do this variable assignment here, we cannot do it. All right. So it turns out this will be some limitation for the compiler, but let me just put it in just for your knowledge, right? For those of you who may have taken, for example, 2001, this will be something that can somehow draw some connection. If you haven't taken that, that's okay, just for your knowledge, all right? So this is what I call an A+ challenge, okay? I'm gonna present to you the problem. If you can solve this problem here in Java, C#, Python, C, whatever language you like, or even assembly, if you can solve this challenge over here, you're going to get an A+ directly. You don't need to take the written test. You don't need to take the programming test. You don't even need to take the exam. You just get A+. No question asked. Okay, here's the problem. All right. You're going to write a program there, and the program is going to take some arbitrary Java program. Let's call that myclass.java, just for example, right? Just a single file. Let's make it simple. Just single file, not a project, just single file. And the file over there is going to contain lines like this. Maybe there's a main method. You can even assume there's a main method. We're going to go from line number 1 all the way to the last line. And then we're going to declare different classes. And then what we want to do is we want to supply a variable name. So this S over here is a variable name. So given some Java file, given the variable name that exists, we want to know from your program just a single output. Tell me what is the last dynamic type for variable S. For example, in this case, let's say there are only 2 lines in the code. Let's say after declaration for S, we simply assign S to be new resident students. So what will be the answer? Resident students. But the challenge, of course, is your program should really handle arbitrary Java program, which might contain variable assignments, if then else, while loop, for loop, etc. Okay? So that's a challenge. And if you can get this done, even after the exam, on the exam day even, I'll give you A+. No question asked, if you can convince me that you got it. All right? So what's the trick here? My advice would be, don't try. Because if you can really solve this problem here, what you really deserve is not an A+ in 2030. What you really deserve is a Nobel Prize. I'm not joking. So this is a very well-known problem that's called undecidable problem. If you actually took or is taking in 2001, you may have heard about this term. So what the computer can really solve, of course, there are many problems that can be solved by a computer, but there are way many more problems that simply cannot be solved by computer. And this is one kind that cannot be solved. Right? I'm not going to take you too much time because you really have to take 2001 and think through about the undecidability. But I just want to tell you that in 2030 context, when we talk about inheritance and typecasting, there is some instance where the compiler just cannot solve it for you. So that's why we have to use typecasting, right? That's kind of the logic. All right, so this guy over here is simply something called undecidable problem. Specifically, in general, you cannot write any program that's actually going to simulate or try to figure out or infer the behavior of another program. It's not feasible. It's not feasible to write a program that infers, that's a little bit more formal term, the dynamic behavior, which means the runtime behavior. Dynamic behavior of another program. It's simply not possible. Okay, so in this case, we cannot really figure out exactly what's after the long execution of anything which might contain for loops or while loop. We're going to basically run through the whole program and figure out what's the last dynamic type. It's not as easy as that. Okay, so just not possible. So now let's go back to this problem here. You might be thinking that for compiler, at this point, they should really know that gym is really pointing to some RS objects. So we should be able to assign RS, should be able to assign gym into RS so we can set premium rate for that objects. That might be what you're thinking. But compiler just cannot infer what's really the dynamic type at this point in general. It's just an undecidable problem. You might be able to solve for this particular instance, but not in general. So there's no such a compiler. All right? So what can we do then? Okay? For us as a programmer, if at this point you are so sure that gym is really pointing to some RS objects, you may actually tell the compiler, trust me, just bypass this, and then I'll tell you what to do. So that's really what typecasting will do for you. All right? Anyway, so when you study later, just in general, I think this understanding that this is really showing some limitation for the compiler is really important. And then for this one here, you just gotta know in general, this kind of dynamic behavior inference problem is just undecidable. No computer can solve it. All right. And then let's not talk about typecasting, right? That will be the syntax you will have to learn. Okay, let's talk about typecasting. And this is really something we also spoke about when we talked about the equals method earlier. But just review a bit. Okay. So the typecasting, you're gonna have some parentheses over here, and inside you're gonna put some class name. Right? And then there will be typically some variable, reference variable. You basically want to cast certain variable into some type. All right? And there will be certain rule, which we're going to talk about. For now, let's just understand the syntax. What we said earlier is pretty much it. The typecast is actually going to create an alias of the same objects. We are not trying to create any new objects, and also we are not really modifying the static type of gym. We're not doing that. So let's just visualize what's happening here. Okay? Let's look at the expression here, part by part. Okay? And I will point out to you the common confusion. Okay. First of all, let's now start with this one here. This is the cast type. So we basically want to cast gym, which is currently students, into the cast type. But be careful here. Gym, the static type for that, is not going to be modified. No. All right? So you want to notice that the static type here never changes. This static type never changes. So what we do instead, just by looking at this expression here, just this, right? This will be the right-hand side. So I'm talking about parentheses, resident students, and gym. Just this expression here. That one there is going to create some anonymous objects, okay, just without a name. That one there is actually going to create some alias over here, and the alias has no name. But what we can do is we can visualize a little bit. We just say that one there really is of an alias of type resident students. And you can think about the resident student over here correspond to the cast type right here. Just an alias without any name. So we got the original gym, which is right here. We got this typecast, which is another alias. You can see this and this are different static types, right? And then, because this is anonymous without any name, we should really give it a name. So what we do is assign this expression here to another reference variable. So we can make use of this. That's what we'll do. So you can see this is a substitution. Okay. So the equals over here will be subject to the rule of substitution. Okay, what's the rule of substitution? It tells you that a static type of the right-hand side, which is resident students, that one there must be a descendant class of the left-hand side static type. Indeed, it is, because resident students is simply a descendant class of itself. So that's good. We deliberately choose a class that's just the same as cast type, just to be safe. But we're going to see a little bit more complicated combination later. All right. Okay, let me recap very quickly. So what we have is, first of all, we got Jim with this static type. And then we do some typecast over here. That one there is going to create an alias of a different static type. We have not modified the static type for Jim. It remains to be students. Once we got this alias over here that has no name, we can store its address into another reference variable. Now we can see that the static type for this expression here, resident students, is a descendant class of the left-hand side static type. So it's going to work. So what that would do is going to, you can think about RS, is actually going to say RS pointing to just the same objects. And then that one there has static type RS. All right? So now the amazing thing is, if you think about it, is this. I want to just show to you, for example, Jim and also RS, right? It's really the Jim here and also the RS. If you simply try Jim dot, for example, set premium rates, it's not going to compile because Jim is of students. On the other hand, if you say RS dot set premium rates, now it will compile because this RS here has a static type RS declared over here. And they're really pointing to just the same objects. But that's really what you have to do as a programmer because the compiler is not able to infer any dynamic behavior in general, undecidable. That's why we got to do typecasting. So what I just said so far in this lecture here is really something very, a bit abstract, I understand that, but that's really the very foundation about why we got to do typecasting and also linked to our issues about expectation, etc. So do review this part here. It's actually quite important. Okay. All right. So this one here is actually okay. Okay. And for now, of course, I deliberately try to simply do a cast that's not going to cause us any trouble. But I'm going to show to you the more general case in a moment. But for now, just learn the syntax. All right. Any question over here? So what's important to pay attention to for this page will be here. Again, you want to understand how we got 1, 2, and 3 different pointers for references of the same objects. All right, that's something you want to pay attention to. All right. Okay, just talk a little bit more about the syntax, and then we can do more. We can do some more example to make it more general. Let's do some syntax as well. Okay, so when you do the typecast, basically either you can make the cast with a name. Okay, so let's just see this one here. So you can also do these yourself as well, but I'll just help you visualize it. So now we're using the smartphone example, right? Let's do this line here first. So here you can see the smartphone right here is at the top of the hierarchy. And then we say a phone has a dynamic type new iPhone 13 Pro, which is right here. So this line is good because new iPhone 13 Pro here can fulfill smartphone. So that line has no problem. And then what we do, but we cannot simply say a phone dot FaceTime. We cannot do that because a phone statically is a smartphone. You cannot say FaceTime. FaceTime is only available for iOS. It's the expectation in the subclass. All right. So what we have to do is, if we are so sure it is really pointing to some iPhone objects, we have to do typecasting. So what we do is we can say now, right here, a phone cast into iPhone 13 Pro. Okay. So let's just see one more visualization. Okay. So I'll just say start over here. Let's just do another visualization just to show to you, right? So we basically got smartphone, also a phone. That one there in the beginning is pointing to some iPhone 13 Pro objects. iPhone 13 Pro object dynamically, all right? And then when we actually do the anonymous cast right here, that one there is going to create some alias pointing to the same objects right here. And that one there has a static type iPhone 13 Pro, all right? And then it has no name. So what we do is we're going to assign that. You can see the right-hand side has a static type iPhone 13 Pro. Can it fulfill iOS? Yes, it can. Because iPhone 13 Pro right here can fulfill iOS. It's a descendant class. Okay, so this one here, so we can say it's called for Hyang. Okay, that one there is of static type iOS, right? iOS. It's just going to point to the same object here, right? So you can really see that what we said earlier about when you are trying to do a typecast, you're really keeping 1, 2, and 3 different references, just the same. It's just that the inheritance hierarchy is a little different right now. Just understand that, right? Of course, ultimately, we're just going to use this variable here to really for any method call, right? You can see for Hyang here, FaceTime, right? But there is a way just to use the anonymous cast as a method call, which I'll show to you. That's also some syntax you can try, right? All right, right here, actually, okay? So you can think about this part over here, rather than assigning that to some name, I can just use it right here, and then .FaceTime. However, you gotta be very careful about how it should be written, okay? I'll point out to you. You can see this part here is really the cast, right? Think about this part here is really the cast. Just this part. Okay, you can see that iPhone 13 Pro is a cast type and a phone. That's exactly what we had on the right-hand side, just the same. But somehow we have to surround it by some parentheses. One here and also one here. This is necessary. All right? We're going to say that, so if you say this one here, do the cast first, and then I'm going to invoke a method call on that particular typecast alias. Okay? So what we're doing here is, so the method call is actually invoke on the typecast alias. And what if you didn't really have that parenthesis? What's going to happen, right? That's another question here. I'll show to you, okay? So now let's now say that, well, this is what we have. What if I simply got this line here? Basically, I didn't really surround it by parentheses. I didn't do that, all right? This one here is problematic. It's really about the order of evaluation, about precedence of the operator. If you actually do this one here, it would be as if you're trying to make a method call first, get its return value, and then cast that into this class. That's what it would mean. But if you say parentheses over here, that would mean I want to do typecast first, and then do the dot notation. Right? You can see the different order, right? Okay, so let me write it down for you. So this one here will be as if. I basically say, I'm going to say iPhone 13 Pro, something I want to cast into, but I'm going to do a phone dot FaceTime first. Right? So this is something I added additionally just to show to you. It will be as if we're doing this. But is this even going to compile, though? Right? You can see a phone is declared to be smartphone. Does smartphone support FaceTime? No, it doesn't. Right? FaceTime is only available in the lower class in hierarchy, not for the smartphone. All right? So this is not going to compile. Okay, we'll just write it down over here. Not compile. All right, so this page here basically just reaffirm about the different references when you do the typecasting, and also how you can use the cast without a name. And also gotta watch out for the parentheses. All right, over here. Okay. All right, any questions about typecast? All right. And let's move on a little bit more, and then we can take a halfway break. Okay, just a little bit more, maybe 5 minutes. I just gotta watch out the time. Okay. Okay, so let's now move on to, okay, how about we do this one here? There's something about upward and downward casting. So now, what class can you cast into? Whenever you do a typecast, you want to think about whether the typecast compiles. If that compiles, are you going to run into any exception at the runtime? So there are two issues over here. One is about only compilation. The other one is if it compiles, are you going to run into runtime issues? So two issues over here. And this page only talks about compilation. Okay? So let's say this. Let's say I have my phone right here. So my phone is declared to be Android. Android right here. Okay, that's my phone. And then I'm just going to box it right here. So Android is right here. And right away, let's now try to see what's the expectation for my phone, right? You can see my phone here is Android. What will be the expectation, right? You can see Android is going to have basically surf web, Skype, dial, right? These are all the things, nothing else, right? That's about expectation. So we have surf web, we got Skype, and also we got dial and surf web. Of course, you got some duplicates over there, which is okay. So what we have is my phone got dial, surf web, and also Skype. Only these three. Everything else is not part of its expectation. And this is nothing new. Okay? Just for this one here. Oh, I can make it a little bit thinner. Okay, this one here, no side sync and nothing else, right? All right, let's now talk about different cast possibility. So here's the deal, right? The rule is you can try to do the typecast upwards, in which case, if you try to typecast to one of your ancestors, let's say like a parents, in which case you're really reducing the expectation for the resulting cast. And you can also try to do downward casting, in which case you can now try to cast downwards to any of your subclasses or their descendants. In which case, for example, if I try to downcast Android down to, for example, Samsung, in that way, I will be able to call side sync on that particular typecast because I'm lowering down the class. Okay? Let's now take a look. So what I'm doing here is you can see my phone here and my phone here, right? Let's now just see different possibility. So my phone. And then this one here is doing downward casting. Upward casting. So this one here is really something called upward casting. Okay, this one here. Smartphone. So we're basically just going upwards and then we're just casting that into the smartphone. As long as it's one of the ancestors, you can do upward casting. In which case, you're really reducing the expectation. So why am I saying reducing? So upward casting. Reducing, or narrowing, doesn't matter how you say that. Reducing expectation. All right? Let's say we simply store this anonymous cast into something just has the same type so we can see, right? What about SP now, right? You can see SP is really pointing to just the same Galaxy S21 Plus. It's the same objects. We're just creating alias. So now for SP right here, what will be the expectation then? SP is now smartphone right here. So we should only be expected to do dial and surf web, right? Should we still be allowed to do Skype? Not anymore, right? So in that way, we're going to have the dial and also surf web. And everything else would not be possible anymore. Okay? I think let's now do one more thing here. So new Galaxy S21 Plus, that's a dynamic type, right? You can think about that's really the single object that always stay there. Galaxy S21 Plus right here, right? Initially, we got my phone right here. My phone of static type Android, okay? Pointing there. After the upward cast that we just did, SP of smartphone static type. So we got SP, that's pointing to this object here. The static type is also smartphone, right? What about we do downward casting? If we do downward casting, what we are saying is we cast that into one of the descendants. And in this case, let's be safe. Let me cast down to its dynamic type. Okay? So what I will do is I'm just going to say I'm going to cast downward to S21 plus, downward here, and also downwards over here, right here. Okay, this is downward casting. Downward casting, which effectively, rather than reducing, is increasing the expectation. Increasing the expectation. And then there's a special case over here because Galaxy S21 Plus also happened to be the dynamic type. This one here also happens to be. Happens to be the dynamic type of my phone. All right, so what we have is we also have another one here pointing to the same object here. That's a dynamic type. And that one there has Galaxy S21 Plus, right? Galaxy S21 Plus. So these three lines over here, my point is there's only one object right there, only one. Depending on which reference you're using, you have different expectation. You can easily create different aliases using typecast. And typecast can either be upward or downward. All right. Okay, let me just complete the table there. And now what about GA, Galaxy, right? So that one there, we are just having more expectation. So here we definitely can do dial, surf web, and also Skype. And also since now we are here, we can also do site sync. Right? Right? Right here. And then the rest would just not be possible. Okay. This page here is not really about general rule just yet. I'm just trying to show you some intuitive cases where I'm just trying to upcast to all the way up to the top of the hierarchy. Also, I can also cast all the way down to the actual dynamic type. Both of them are actually okay, but just trying to show to you, you can either cast upward or downward. Of course, we got to see the rule as well. All right. Okay, I'll suggest we pause a little bit by taking attendance, and then we'll resume. Okay. So let's now talk about, just before I move on, I think your fellow student asked a very good question right before the break. Maybe that's something I didn't make as clear. So when you talk about upward casting and downward casting, right? For example, this one here, why is it upward casting? You have to look at the static type for my phone. My phone has a static type Android. If you want to go for Android to smartphone, you're going this way. So that's smartphone. You only look at the static type. On the other hand, if you look at this expression here, I'm trying to cast my phone, again, declared to be Android right here. You want to cast that to Galaxy S21 Plus, which is down over here. So we're doing downward casting. So on the slides, there's a PDF over there of some notes. You may want to take a look at that notes as well. That will also try to explain how things work. But that'll be a nice compliment, for you to study for the test and for the exam. All right. So before I try to make everything general, not yet, but we want to talk about one more thing. Let's say if I do some cast, right? I know that if I do upward casting to any ancestor, or if I do downward casting to any descendants, I'm basically just playing with the expectation. Either I can try to make the expectation less, or I can make the expectation more. However, can I always do this without any risk of runtime exception? The answer is yes, you do have the risk. And you got to be very careful, all right? Especially, let me just do a little bit hand waving. Whenever you want to do my phone and cast that into Galaxy S21 Plus, compilation-wise, you're okay because you're doing downward casting. However, at the runtime, what the runtime with Java Eclipse or Java execution machine, they will check for you, can the actual dynamic type fulfill the expectation that you're trying to cast into? If you can fulfill, good. If you cannot, some exception. I also briefly mentioned that maybe in the earlier class. That's something we've got to look at now in more detail. All right, let's look at one scenario, simple one. So guys, again, can you please look at these three lines just for about 30 seconds? Okay, just take a look. Yeah, just think to yourself, is everything going to compile? Number one. Number two, if it does compile, is it just going to run without any issue? These are the two questions you want to ask to yourself. I'll give you a little bit hints. If you look at line number 2, when we are doing casting, especially we're doing casting from gym into resident students, are we doing some upward casting or downward casting? If we are, most likely then you should compile. If that compiles, the next question will be, at the runtime, what's going to happen really? Right? If you visualize what's happening here in the object diagram, you might find that something is weird. Okay. Okay, let's now take a look. First of all, this variable assignment here is good because non-resident student can fulfill students, so we're good. That's polymorphic assignment, right? Just variable assignment. So now just this cast alone is okay. Because if you just look at this cast over here, if you look at Jin, over here, Jin and Jin has the static type students, which is right here. So you can think about this is the static type of Jin, right? And I'm trying to cast that to resident students. So I'm saying that given that Jim is a static type student, I want to cast that to resident students. Downward casting, nothing wrong, all right? So this one here, resident students, is the cast type. And this, as far as compilation is concerned, compiles. Because it's downward casting. I'm casting to one of the descendants of the static type. And of course, once you have done this, the static type for the right-hand side can fulfill the left-hand side. They're just the same, right? And then here, once we have done that, so RS is now static type resident students, set premium rate should be good, right? Compilation-wise, these three lines are okay, we are safe. What about runtime? Let's now try to execute the line one by one. That's the funny part, really. So because, well, in some ways it's not really funny because whatever that compiles doesn't really guarantee it's going to work at runtime, right? You know that pretty well. I know that pretty well too. We can all make a mistake. So let's see this. So at the runtime, we are going to do this. Let's now execute the code one by one. Line number 1. What we get is we got some students, Jim, and then pointing to some non-resident students objects, right? Notice that that's the dynamic type, right? So this is the non-resident students, which has the discount rate. Oh, sorry, discount rate right here. This is just 1, right? I'm just using blue. And then what about line number 2? Line number 2, we're doing the following. We are saying that, first of all, just for this part, for the typecast, we're creating some alias. And this alias over here is going to be of static type resident students. All right? So now, this is another question you want to think about, right? At this point, Java runtime is going to have going to be triggered the alarm. You are basically saying you have some static type resident students for this particular object. That means this alias will be expected to use as if it's a resident student. That tells you that the expectation later will be, for example, premium rates. Now, does this dynamic type right here, this object here, does it provide premium rates? No, it doesn't. It's a non-resident student object. It only has discount rate. This incompatible expectation. Okay? And in this particular situation over here, okay, so now for the star. Casting a non-resident students objects to type resident students, right? We're casting that into resident student right here. Triggers a class cast exception. Okay, so this is the very first time we talk about this exception here. Class cast exception. Okay, I will highlight the name. Class cast exception. Because the dynamic type NRS cannot fulfill the expectation for the cast type. Okay, I'll write it down. Okay, writing outer space, I'll just put it right here. Okay, I'll put it here. Because the dynamic type NRS cannot fulfill the expectation of the cast type RS. Dynamic type is right here, non-resident students. So this is the dynamic type. And in order for this cast to really work without any class cast exception, the dynamic type for Jin must be able to fulfill the expectation for that. That means the dynamic type must be a descendant class of resident students. But in this case, it is not. It's actually non-resident students. All right? Tricky, but it's still kind of a consistent with what we said earlier about expectation. Let me recap. From line number 1, what we have is we have Jin pointing to this particular non-resident student objects. Non-resident student objects can only fulfill non-resident students or students, nothing else. And then in this particular cast over here is a downward cast. We're saying that let's cast this particular object down to resident students. We cannot do it at the runtime because non-resident student just cannot fulfill resident students' expectation. All right. This is a tricky part you want to think about. All right. You can also take a look at the slides, which I also try to explain over there. Okay, that's the intuition. Okay, let's do one more quickly. Okay, again, take a look at these 3 lines for 30 seconds. Okay, similar. Just before, yeah, go ahead.
So in the previous example, can you go back one slide?
Yeah.
Let's say resident student and non-resident student had the same double and the same function, right? But they had different names, right? So one's resident student. If you, technically there's the same data in a sense, right? But can you cast from one to the other if, say, there's the same both variables and methods?
I know what you mean.
Same exact code.
The short answer is no. Because the compiler or the runtime is not that flexible. It does not really try to compare exactly what's the attributes or methods in that particular class. You only look at whether they are either descendant classes relationship or sibling class relationship. Okay, I'll show you here. Okay, that's possible. I think this is kind of expected. You know, every year, you know, every time I teach this subject here, there's always good students, you know, who actually will talk about some deeper insight. I'll talk about exactly what your fellow student was trying to point out. Let's say this. We got A, and then child number 1, and also child number 2. Oh, you know what? Let me make it P, parents, more explicit. Let's say in the parent class, we only got some integer I. All right? Let's say we don't introduce any new attributes in C1 or C2. Let's say we don't. So C1 and C2 are basically the same class, just different name, right? So now, if I try to do this, P, let's say objects, new, C1. So that means OBJ dynamically, statically is P, but dynamically it is pointing to some C1 objects. And that one there only has I. All right? Good. And then let's now try the following. This will be number 1 and number 2. Let's say we try to do some typecasting. So I will simply say C2, and then I would say object 2 will be, I try to cast OBJ, statically it's a P. I'll do downward casting. So downward casting from P down to C2, which is okay, compilation-wise. Okay, like that. So this is the line. All right, this one here. And it's a downward casting. Downward casting. Okay, let me move the diagram here so you can see a little bit more clearly. Okay. Now the question is, given that C1 and C2, they are basically identical. It's just that their names are different. Are we going to run into class cast exception? Given that it's okay. Yeah. Let me just change the color first. Okay, like that. So now you can see C1 and C2 are basically identical, except name difference. So now when we try to do the typecast, right here, when we try to do this one here, we are saying that we are trying to create an alias over here, and that one there is going to be statically C2. Now, whether or not there should be a class cast exception is determined by whether or not the C1 can fulfill expectation for C2, right? That's something we said, okay? So class cast exception, whether or not it should happen, depends on can C1 fulfill C2. Okay, I'll make it a little bit briefer, okay? Again, let me remind you the C1 over here is the dynamic type that we're talking about. And also the C2 is the cast type that we are talking about. Okay, just make everything clear to you. Okay, these two. It turns out it cannot, even though they look identical. No. Class cast exception will occur. Two things I want to say. Number one, at the runtime, at this point, to determine whether or not class cast exception should really occur, we want to see whether C1 can fulfill C2. To really determine if C1 can fulfill C2, we do not try to compare their contents. Because sometimes maybe they both have integer, but maybe different names of the integer. One can be I, the other one can be j. Well, we don't even know if I in one class mean the same thing as I in another class. There's no general way to tell that. So even if they are identical, it's not what the decision is going to be made. All that would be made would be whether or not C1 is a descending class of C2. Simple question. It is not. Okay, over here. The only question is C1 a descendant of C2? In this case, it is simply not. If it is not, class cast exception. Okay? And let me give you a little bit more insight. Okay? So it's a very reasonable decision. Even though at the moment C1 and C2 they look the same, but very, very likely because your software project may not be just a one-off, it may be ongoing. Maybe at some point in the future, maybe you will decide to maybe add some attributes or method to C1 only. In which case, from that point, C1 is already different from C2. Right? So just to be assuming that your software project is going to be going on, and also the reason that you create a subclass over here is really for creating some unique attributes and methods. That's more like a design principle, right, for cohesion. So it's safely assumed. Later on, C1 and C2, they will be very different, even though they might be identical at the same time. Okay? So this example here is definitely relevant. Okay? It might appear at some point, maybe not in the Friday's test, I'm not too sure, or maybe in the exam. Let me recap. Whether or not you should really get a class cast exception at the runtime, you only look at whether or not the dynamic type can fulfill the expectation for the cast type right here. That's all you look at. And to really see that, you try to see whether the dynamic type C1 is a descendant class of the cast type C2. If it is not, class cast exception, no question asked. Okay. Good, okay. Alrighty. Okay, that's all good. Okay. So why don't we do one thing very quickly. Okay. Guys, how about let's do one more example, okay? Let's look at these three lines very quick. Again, 30 seconds, right? Okay, so let me now present maybe slightly a more efficient way, okay? So first of all, you can see that smartphone over here is the static type of the variable. And then we can see that this is the dynamic type, Galaxy S21 Plus dynamic type. And then we're casting a phone, which is a smartphone statically, to iPhone 13 Pro, which is right here. So we're doing downward casting. Agree? Okay. So that one there is iPhone 13 Pro. This is the cast type. Compilation-wise, this is good because we're doing downward casting. Are we going to run into class cast exception? All right, so now all we ask would be, can the dynamic type fulfill the expectation of the cast type? It will only be okay if this is a descendant class of that. No way. It's too far away, right? It's definitely not a descendant, right? Class cast exception. All right, so right here, at this point at the runtime, compiles, but class cast exception, because the dynamic type Galaxy S21 Plus is not a descendant of the cast type, which is iPhone 13 Pro. Right? So that's a complete reasoning. Oh, you know what? Okay. Similar to the previous example, but I'm just trying to give you a different hierarchy. Okay. All right. And then you can also try to do this exercise yourself, right? Similar. Okay, I'll leave that empty for you. One here and one here. You will see also the answer on the slides. All right. Okay. Okay. Let's see. Okay. Let's now do generalization about a rule. Okay. So here's a rule. Okay. Given some inheritance hierarchy, now we want to distinguish between four categories. If you're trying to do certain cast, cast may be compilable or not compilable, right? Two categories. When the cast can compile, is it going to throw some class cast exception, or is it going to be exception free? So these are different categories. All right, I'm going to summarize it. The good thing about it, if when you try to see this one in a more like a higher level and more intuitive way, it can help when you go back to the detail, right? Let's do that. Let's do one by one. First of all, let's now look at this line here. We got Android, which is smartphone. Oh, sorry, beg your pardon. We got Android here, which is the static type. Sorry, let me just take a look at my notes, just to be sure. Okay, good. So what I want to do is, let's now do this one here. So we got Android. That is the static type of the variable. Okay, so this is the static type. And also we have Samsung. And that one there is the dynamic type, right? Just make sure we understand where we are in the hierarchy. Dynamic type. Okay, so now, based on these two types, static type, dynamic type, we can now figure out the range of different possibility for typecast. All right? So now we want to look at, when I try to write any line like this, if I write a line like a my phone, right here, and then I'm trying to cast that into some class, question mark. And the question mark over here can be any of the classes in this hierarchy. Now I want to understand if I try each one of them, am I going to either, number one, compile or not? Number two, if it compiles, am I going to get class cast exception or not? Right? So these are the things we want to go over. Okay, let's now take a look at compilation. Compilation, just remember, either do upward casting or downward casting, right? So you can think about, you can either do upward or downward. So compilable cast, it can be either upward or downward. Okay, in which case I'm just gonna just highlight them. So you can see Android, this is where we start with, the static type, right? If you do upward casting, there's only one choice, smartphone. But if you do downward casting, it can be this, 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 right? You can see everything that's either casting to the static type's ancestor or the static type's descendants is going to be compilable cast. Everything else, meaning that if you try to cast to a class that's neither ancestor nor descendants, is going to be not compilable. Okay, in that case, it will be iOS, iPhone, and iPhone. Intuitively, you simply say, if I got an Android phone, there's no way I can use the Android and let it fulfill iOS. They're simply different category. But if you look at inheritance hierarchy, just look at descendants versus ancestor. Okay? So these are neither ancestor nor descendants. All right. So there's not too much to say about these three because they simply wouldn't compile. End of the story, right? If that doesn't compile, you cannot run them. So let's now talk about these, right? Given that if you try to put one of these classes as a question mark, it's going to compile. But what if you run the typecast at a runtime? Some of them are going to give you class cast exception. Some of them will not. So now the idea would be, if the class type, if the cast type right here is one that can be fulfilled by the current dynamic type, you are safe from the class cast exception. All right? Class cast exception. Class cast exception. If the dynamic type cannot fulfill the cast type. So now you want to think about, what can Samsung fulfill? Samsung can definitely fulfill itself. Samsung can definitely fulfill any of its ancestor, basically. That means we can cast that into Samsung itself. We can cast that into Android. We can also cast to smartphone. These are the only two possibilities. These are the only possibility. Okay, so blue. So I'm going to do right here. Okay, like these three classes. I can do a little bit better. Okay. Okay, like that. So these three classes basically are the ancestor of the dynamic type right here. That means their expectation can be fulfilled by the dynamic type. And then you can see that, for example, Samsung over here cannot fulfill Galaxy S25 Plus, even though at this point these two classes might be identical, which I just covered, right? Even though it might be identical right now, but later on you might expect something new to be added later. So as long as the cast type over here is not an ancestor for this dynamic type, it's not going to work. All right? Okay, so now you're going to say this. So this one here, these classes, anything right here. All right? So these are not going to, going to give you the class cast exception. Class cast exception. Because they are not ancestor of the dynamic type. Right, so that's a full story about typecasting. Let me make some recap. We still got 5 minutes. I think we can do one more exercise just to reaffirm your understanding. Okay, so basically, when you study for Friday, start with what's the motivation for typecast, what's the syntax, how do you do anonymous cast, and also think about what's really the circumstances where a typecast will actually compile or not, first of all. If that compiles, are you going to run into class cast exception? That's another binary choice. Okay. Okay, we got 5 minutes or 6. Let's now do one more exercise. Okay, nothing new, just do exercise. And I think I'm not going to cover instance of operator, so I'll shorten the coverage for the written test. I'm going to update that a little bit later tonight. Okay, but I'll let you know later. Let's look at this example here. Okay, let's do it right here. We got 5 minutes. I would like you guys just to take maybe about 5 minutes. Oh, no, not 5 minutes. 1 minute, up to 1. Okay. This is the exercise on, slide number 67. All right? All right. So now, this is also part of the practice question I gave to you, right? Given this particular class declaration, can you draw the inheritance hierarchy accordingly? Why don't you take 30 seconds to draw that? On your iPad, on your paper, on your mind, that's okay. That's something you're going to do, right? For sure on Friday, also on the exam. Yeah, take some time. Okay, just 1 moment. Shouldn't be too difficult, right? Alrighty. This is something you should get, I presume. Okay, double check. Class A, B extends A, B extends A, C extends B, C extends B, D extends A, D extends A. All right, it's working, good. All right, now let's consider these 2 lines, all right? Let's now identify the static type and dynamic type. Static type is B. Dynamic type is C, right here. So this is the static type, and this one here is the dynamic type. All right? And now, look at this line here. Okay? That could be a nice rehearsal for your test on Friday, right? Question here. Is it going to compile? I heard no. Can anybody just try to explain why is it not going to compile? Not compilable cast. Okay, it's neither ancestor nor descendant, right? Very good. Thank you. Okay, so this cast over here is not going to compile. Not compile. Because D is neither ancestor nor descendants. So I cannot do downward or upward casting. However, I can make this work. How can we write a little bit more complicated cast exception? How can we write a slightly more complicated class, like a cast expression to make this work? My hints to you. We somehow want to cast into D, right? Here's the hints. What does it mean? I know that I can do upward casting. I know that I can also do downward casting. Why don't I do some upward casting followed by downward casting? Then I can do compilable casting from B to D. Sounds weird, right? It's going to work. Okay, let's write it down. So what I have instead will be something like this. Okay, this will be the last bit for today, so bear with me, please. D and D equals, so I'm going to say B here. First of all, I do upward casting to A. And then I do downward casting to D. All right, so the parenthesis over here is important. Say upward casting must be done first. So this guy here, this is upward casting. And this one here is downward casting. Okay, just to explain a little bit more. So this expression here has a static type A. So I'm casting A downwards to D. Right? Compilation-wise, I'm okay. It's going to compile. But what about the runtime? You can fool the compiler, but at the runtime, it's still only one object there. Right? So what's happening here is, okay, let's see this. Okay? So we are still getting just the runtime C. Guys, please give me 3 minutes, and then we'll be done. Okay, give me 3 minutes. At the runtime, we're still getting the objects of dynamic type C, right? You can see C here. Okay, and then so B is pointing to it right here, and then we are creating some alias over here. That's a upward casting. So we got A here, and then B. That one is also going to point to this object here, right? And then from there, we're going to do another downward casting, right? So let's talk about runtime. What's going to happen? Is this upward casting going to work without class cast exception? The question to ask would be, can C fulfill A? Can C fulfill A? Yes. Upward casting is fine. Okay? So this particular upward casting has no class cast exception. That's okay. The problem happened in the second phase, where we are trying to say, once I go to the top, I also try to go down. That's where the trouble is at the runtime. So now if I do this downward casting over here, now the question would be still, can C fulfill D? Can C fulfill D? No. It can only fulfill if D is an ancestor of C, but it is not. Okay? I'll make one more remark, and then we are done. Okay? So here, D here, so we're going to get class cast exception because C, the dynamic type, cannot fulfill the cast type D. All right, so this will compile, but it just wouldn't, you would just trigger class cast exception. Okay, guys, one more thing. This one you'll be interested. Okay. If you remember, in your lab number, okay, whatever. So let's say this. Let's say in your lab number 2, we have a class called vaccine. And then for your lab number 4, we got something called channel, for example. Okay? Vaccine V, channel, I'll just say channel. Okay. Now, is it possible for me to cast from V into static type channel? Apparently, these are two totally not related classes. But can I do it? Now, I don't have that smartphone or student management system or this inheritance hierarchy with me anymore. I'm just saying in general, I give you two arbitrary classes. Can I simply cast from one to another based on the principle I just said? The principle I just said there was start with the class you want to start with, cast all the way to the top, and then cast all the way down to where you want to be. How about here? How can I cast the vaccine to all the way to the top? Where's the top in Java? object, because everything is a subclass of objects. I can cast V all the way to, okay, this is the final thing, right? I do appreciate your patience. Let me finish that. Cast the V all the way up to object. This is always going to work. And then this static type here is now objects. I can downward cast to any class I like. I can downward cast to channel. This is going to compile, but most likely you'll run into class cast exception. All right, so this is really just to play with what's going to compile versus what's going to behave at the runtime. All right, so I can now confirm for your written test on Friday, you're going to study up to slide number 67. Okay, that's it. Thank you so much.